Hey guys, welcome back to a new video. And in the last video, we looked upon scalar quantities. What are scalar quantities? Like we did looked upon scalar and vectors interview. Like what are these? These both are physical quantities, and we looked upon scalar quantities. That was quite a simple topic. And in today's video, we're looking into another simple topic, that is the vector quantities. We'll be looking into the vector quantities, the tensor quantities. We're looking what does these quantities mean. In the scalar, there was a concept that all the physical quantities, like we have given conditions, like if a quantity is scalar, it should obey rules. What are the rules? They are physical quantities. Of course, it is whether scalar or vector, it should be scalar. It should be a physical quantity. There are specified ways of basing on magnitude. uh, you know they are specified on basis of magnitude, like magnitude is must for them. They have no directions, like they do not require directions. Like we have got mass, so we cannot say that 100 kg in east, it would be same in the west, north and south. While if you are confusing between the weight, like weight is different on moon and earth, so that is another case. Like, to remember that there is a difference between the mass and weight. We will be looking into that topic in one of our videos. Maybe we have done with that. Moving forward, focusing on the main topic, we will be discussing about the vector quantities today. So vector quantities, I'm just writing in short forms, you need to understand. Okay, so vector quantities, as always, like we have got two they are of course physical quantities. P dot q, that means they are physical quantities. Like uh, you know every, whether scalar, vector or tensor, that would be I've just mentioned here there are two types, but you do need to remember that we have got a subcategory of vectors that is known as the tensor quantities. We're looking into that. These are also, all of these are physical quantities. That is a must point. Moving forward, we've got a second point, that is that vector quantities do depend upon uh, directions. Like they they are having they are having magnitude as well direction. What does it mean? Like these both things are must. Like in scalars we have got only magnitude, but here we have got magnitude as well as direction. Both are important. So uh, direction, like east, west, north and south, that is important. Like a direction has an impact on the vector quantities. Likewise, it has no impact on the scalar quantities. The mass would be same in all direction, but a vector quantity would not be same in all the directions. That may depend on the directions. Moving forward, we've got another point, that they obey rule of factor addition. So that is kind of a rule, and you might be confused at what that rule is, and you don't need to confuse now. But just remember this point, that uh, you know you just need to remember this point, that there's a vector quantities do obey rule of factor addition. We'll be looking into the rule of factor addition in upcoming videos. For now, you don't need to confuse, just remember this point. Okay, let me give you some sort of examples for the vector quantities. Like examples examples would include weight. So here comes the case when you if you guys are confused between mass and weight. So mass is similar in all the direction. You will be having the same mass over here and on the moon, but you will be having a different weight on earth and on moon. That is due to directions. Like directions have impact on that. So that means that weight is a vector quantities. Like 10 newton, 10 is the magnitude, and newton is showing the Newton on the moon, 10 Newton on the moon. In the same case, we are having a unit and numerical that forms a magnitude. 10 Newton is a magnitude, and towards the east, towards the west, on the moon, on the earth, that would be its direction. Okay, so um, let me take an example, like we have got torque. Yes, torque is a kind of force. A torque is a kind of pulling force. A body faces torque force when it is hanged somewhere. Like if you hang a pendulum, so from the string there would be a force between the pendulum and the string. That would be the torque force, and that force would be dependent on direction, like on what direction the pendulum is, and that would be more if the string if the string direction is more towards, there is more movement, or the direction, if the direction increases, so there would be more torque. If the direction decreases, there would be less torque. And similarly, it is having magnitude. I do hope that got cleared. uh, let me show you the tensor quantities. We have got another subcategory of vectors, that is tensor. Maybe you have not this is not included in many of the books, but we are looking into it. But tensor quantities, they have all the same like vectors, like as they are subunit, or sub quantities of vectors, so they have all the same features. The single we have got a difference is that uh, all same. Let me write this point first. All same as vectors. You not need to confuse with scalars as vectors. What is the difference then? Difference comes here. Sorry, difference comes here. Don't obey rule of vector addition. So we don't need to confuse that what is vector addition. But look into this point. We're looking into what is the rule of vector addition in upcoming videos. But till now you need to remember these points, like tensor quantities. We have got an example of them as well, like current. Current is said to be a tensor quantities. It is said that tensor quantity, it is a vector, but it does not follow the the rule of vector addition. We have got voltage, resistance, pressure. I'm writing capital V for voltage. We've got resistance. There are a lot of. They are kind of related to electricity, but don't confuse that there will be always related to electricity. Like pressure is not. So I do hope that got cleared about this. We'll be talking about the representation of a vector in our upcoming video. Till that, goodbye.